so we reviewed trigonometry for Math 2 and Math 3. And when we did trigonometry in Math 2 and Math 3, we always focused on sine, cosine, and tangent. But there are actually 6 trig functions, so we're going to learn all 6 of them today. And your learning target is I can find the 6 trigonometric functions. Okay, so just some review that we need to go over. Trigonometry is the study of relationships among the side and angle measures in triangles. A trig ratio compares the lengths of two sides with respect to an acute angle theta, okay, in a right triangle. So this right here is theta. That's just a Greek letter. Anytime you see that, it's talking about an angle. And then a trig function is a rule defined by the trig ratio. So just some things that you should remember. The opposite side, they call it OPP. You know what I mean? Okay, that's a rap song. Don't look it up. And then the hypotenuse is across from the right angle, and then the adjacent is always touching theta. So those are the 3 things you need to understand how to find. Where is the opposite, where is the adjacent, and where is hypotenuse? And is always in relationship to wherever theta is located. Okay, so here's your 6 trig functions. So the first 3 you should already know. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And that's when we use some old hippie called another hippie tripping on acid. But there are 3 more, and they're new to you, probably. So cosecant, secant, and cotangent. Cosecant is abbreviated CSC, and it's the hypotenuse divided by the opposite. Secant is abbreviated SEC, and it's hypotenuse over adjacent. And then cotangent is COT, and it's adjacent over opposite. So if you look at these, they are reciprocal, so they're just flipped over. So we call them reciprocal functions. So because the cosecant, secant, and cotangent ratios are reciprocals of the sine, cosine, and tangent, they are called reciprocal functions and can be defined as, so cosecant is the same thing as doing 1 divided by the sine function. The secant function is the same thing as doing 1 over the cosine function. And then the cotangent function is the same thing as 1 over the tangent function. So they all work together, and so the 3 new functions are just flipped over the functions you already know. Alright, so let's look at this. We're going to find the exact values of the 6 trig functions. Okay, so if theta is right here, then this side has to be my opposite. 13 is directly across from the right angle. It's also the longest side, so that's my hypotenuse, which makes 5 my adjacent side. So remember, you have to understand how to find those in relationship to theta. Okay, so remember, sine is opposite over hypotenuse, so it would be 12 over 13. Cosine adjacent over hypotenuse, so 5 over 13. And tangent is opposite over adjacent, so it would be 12 over 5. Okay, so look how easy this is. Cosecant is just sine flipped over, so it would be 13 over 12. Secant is just the cosine function flipped over, so it would be 13 over 5. And tangent is the cotangent flipped over, so it would be 5 over 12. So these are just really easy. They're not bad. Let's look at the next one. So we have the hypotenuse is 29. It's my longest side. It's across from the right angle. I have my adjacent side of 20. I don't have my opposite side, but I should know how to find this. This is a right triangle, so I can use Pythagorean theorem really quickly. Pythagorean theorem says a leg squared plus a leg squared equals hypotenuse squared. So if I do this, I should get that. Oh, sorry, I just erased that. X equals 21. So my hypotenuse is actually 21. So now I can fill in this information. So sine is opposite over hypotenuse, so 21 over 29, which means cosecant would be 29 over 21. So you just flip it. Cosine is adjacent over hypotenuse, so 20 over 29. So if I did secant, I just flip it. And tangent is opposite over adjacent, so 21 over 20. And cotangent, just flip the tangent. Alright, so that's how you get this. Alright, so now we're going to do the same thing we just did, except we're not given a triangle to look at, we're given a ratio. So we're going to kind of work backwards. If you remember that tangent is opposite over adjacent, it's literally telling you what your opposite and what your adjacent are. So you could actually draw a right triangle. That's what I do. Label theta somewhere. So if theta is here, then my opposite would be here, 7. My adjacent would be over here. And then I could use Pythagorean theorem. 7 squared plus 24 squared equals x squared. And I get that the hypotenuse is 25. So, when you're given a ratio, you just use the stuff that you did in Math 2 and Math 3 and the Pythagorean theorem from middle school, and you can work backwards, and now you can draw your own picture, and then you're good to go. So the sine is opposite over adjacent. Opposite over hypotenuse. Let me try again. So it'll be 7 over 25, which means my cosecant is 25 over 7. My cosine, adjacent over hypotenuse, so 24 over 25, so secant would be 25 over 24, just flip it. And my tangent is opposite over adjacent, so 7 over 24, and if I want to do cotangent, I just flip it. Okay, so what I want you to do is I want you to look at the second one, and I want you to see if you can draw the right triangle. So I want you to label the adjacent, the opposite, and the hypotenuse. So obviously you're going to use the Pythagorean theorem to figure out your missing side. But see if you can do this problem. Pause the video and actually try it in 1, 2, 3. So hopefully you remember that cosine is adjacent over hypotenuse. So you actually do have 2 values already given to you. So my adjacent would be over here, it's 5. My hypotenuse would be here, 9. And then I would use Pythagorean theorem to figure out what my opposite side would be. Alright, so it's going to be a little weird because you should get 56. And when you take the square root of both sides, x equals, and you have to remember something from Math 2 and Math 3, 56 is not a perfect square, but what we can do is find the biggest perfect square is divisible by. So 4 and 14 multiply to give me 56. And the square root of 4 is 2. So what I'm going to write as my opposite side is 2 square roots of 14. And I just want you to understand that you're just using previous math skills learned from previous math courses. Whether or not you learned them, you were taught them. And that's what we're using to get this. Okay, so now when we fill out the chart, okay, so sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And tangent would be opposite over adjacent. Okay, so when I flip the fractions, here's some more stuff from previous math courses. We don't ever want to write a radical on the bottom of a fraction. It's just not grammatically correct, kind of. So what you do is you would multiply the top and bottom by that radical. Alright, so the top you just multiply across. It will be 9 square roots of 14 over. On the bottom, you have 2 times. When you do square root of 14 times the square root of 14, it's just 14. So this will be 9 square roots of 14 over 28. And then you can reduce, no you can't, 9 over 28 doesn't reduce, so that's actually your answer. So 9, sorry, wrong box. It's going to be 9 square roots of 14 over 28. So I just want you to understand that if you were looking at this on a quiz or a test, you would see this simplified fraction And I want you to understand how we're getting that. So you never want a radical on the bottom. Okay, the secant's really easy. All you gotta do is flip the fraction. That one's nice. But then cotangent, you'll see once again, if I flip the fraction, I have a radical on the bottom. That can't happen. So multiply the top and the bottom by the radical. The top you just multiply across. The bottom is 2 times, remember the square root of 14 times the square root of 14 is just 14. So it'll be 5 square root of 14 over 28. And I'm pretty sure 5 over 28 doesn't reduce. So my answer right here is going to be 5 square root of 14 over 28. So there's still ways, if you're not a great math student and you don't remember this and it's freaking you out, you can still put this in the calculator and get a decimal, and you can still figure out the right answer without having all the math skills. Okay, so trig values of special angles. So when we say special angles, we're talking about special right triangles. 30, 60, 90 is very special, and 45, 45, 90 is very special. And we're going to see that again when we're doing the unit circle and all that stuff. Okay. So here's what we're doing, and you just kind of got to know this. If I want to do the sine of 30 degrees, it's equal to 1/2. The sine of 45 degrees is the square root of 2 over 2. And the sine of 60 is the square root of 3 over 2. So if you know just those, then you can make your own right triangle and you can figure out all of these. But these are a big deal, and you'll just need to know them. And then I'll show you some videos of how you can derive them if you forget. Alright, but fill out your little chart. These are the big special angles. You're going to see these come up again. Alright, notice for all of these, we don't have any radicals on the bottom because that's not grammatically correct. These are just your big trig angles that you need to know. And you can use your calculator to find these out. So it's not something you have to memorize, but if you're not going to memorize them, then you have to know how to derive them to get to them. Alright, let me know if you have any questions because this is pretty difficult stuff. Bye.